Hello, so today we are going to take a look at more built-in delegates from Kotlin standard library. Today we are going to take a look at vetoable and observable, which are two built-in delegates, and then we are going to take a look at another one called observable property, which is what is back in both. Observable property, which is like the base class that based on it we implement both. Kotlin standard library implements both vetoable and observable. So let's get started. So first let's start with vetoable. So vetoable basically returns you it's a function, right? It's a function in Kotlin standard library. It returns you a read-write property delegate that calls a specified callback function when the property is changed, and that callback can allow or disallow a modification, which means basically that callback can veto a modification, can say no, this modification cannot go through, which means basically the value will not be updated based on some condition. But if some condition is returned true, then it will update it. If it's false, it will not get updated. And so the syntax of that function is just like you provide the initial value of the property, and then you provide the function that called onChange here. And this is just a callback that gets called before changing the property value. And so if the callback returns true, the value of the property is set to the new value. And if it returns false, the new value is discarded and the property remains with its old value. So that's what it does. So if it returns true, then the value will be changed to the new one. If it returns false, it will not be changed. So let's take a look at some examples to understand. So the first example here, we are going to use vetoable to allow setting a value only to a value bigger than the value that it already had. And so the vetoable gives you the onChange function has three parameters: the property itself, which is just k property, which just has the metadata of the property, its name and things like that. And then you have the old value of the property before this change, and then the new value that we want to change the property to. And so that's these two, old value and new value. And in our example here, we will change the value only if it's bigger than the old value. So we do this, which means if it's bigger, it will return true, so the value will be changed to the new value. But if it's smaller or equal, then we will not change anything because this will return false. And so we will effectively just veto the modification. So let's take a look at an example here. So let's say I have this v value, so it has initially value 0. So if I print it here, it should return 0. And then if I set it to 10, 10 is bigger than 0, so it should go through, so it should be set to 10. But if I set it to 5, the old value is 10, the new value is 5, it's smaller, so this should return false. And so the value should not change, it should remain the old value, which is 10, right? So let's run this and just see if that's what's happening. And that's exactly what's happening. So 0 first, and then if we set to 10, it's bigger, so this returns true, so it passes. If we set to 5, it's smaller, so it doesn't. And so the property still has the old value. Okay, so next, let's take a look at another example, just to make sure we understand. So here we don't allow setting age that is below 0, which makes sense, right? And so I have just this age property here of type int. The initial value is 0. And since we don't need to check old value, we want to check just the new value is bigger than 0. Then we just specify here the new value parameter, and we allow the modification only if new value is bigger than 0. If it's smaller, then we veto the change and it doesn't go through. And so you can imagine this. Let's actually just write a small example here. So if we do age equal to 14, it should go through. So if we print this, age will go through. And one thing to highlight also, this is a top level property. So again, this vetoable, just like any other delegate property delegate, it can be used in local properties, it can be used in top level properties, it can be used in class properties as well. And so if we try to set it to something below 0, let's say -1, and then try to print it, it should remain the old value. Okay, let's run this. And you can see here, the second print, it's still the old value, right? Okay, let's comment this. Now, another example we want to take a look at is, let's say we want to change to a new string. We want to change a property value to a new string only if it starts with the previous value. These just more are examples for illustrations, but if you encounter in your app, you probably will get more like some examples that more make sense. But the example here is we want to change a new string value only if it starts with the previous value. So we need to use old value and new value, right? And so we allow modification only if the new value starts with the old value, right? So if we take a look at the example here, I'm calling it a change because like it needs to change the old value with the new value. And so here we have, first we assign value first, right? Since the value at this point when we initialize is empty string, every string starts with an empty string. So this passes through and the value should be set to first. But here, when we set the value to second, second doesn't start with the old value, which is first. So this should not pass. So we should get first still, right? So here, we should get first. And here, it should work fine. We should get first because the empty string first starts with the empty string. Here, second doesn't start with first. So we will remain with the old value, which is first. Here, we have first and second. So this new value starts with the previous value, which is first, right? Which is this one first. So it should go through. So we should have first, second, right? So let's run this and see if it works. And it does. So first we print first here because this returns true. Before change returns true. Then second, it will return false because it doesn't start with, so the change doesn't go through. And then in the last example, first, second, this phrase here starts with first, and so it goes through and it is set. Okay, another last example just to make sure we really understood. So let's say we want to set a list value only if the size of the new list is bigger than the old list. So we have a list property, we want to change it only if the new value has a longer size than the previous value. And so here, if the new value size is smaller than the old value, then we should just say it's an invalid size, we return false, right? When it returns false, the change doesn't go through. When it returns true, the change goes through, right? And then if not, which means it's bigger or equal, then we print that it's a valid size and we return true. And in our main function here, let's say we have this new list that is 3 elements, A, B, C. We print it. It should be set, right? It should be set because the previous value was an empty list. Here, the initial value, empty list. So empty list size is 0. This value, the new list of size 3 is definitely bigger, so it should go through. So it should print us valid size and go through. So let's first just make sure of that first part. Okay, so it's set to ABC and it printed valid size, right? Now, if we go to the second example, now the new value is ABC, right? And we try to set just A, which has size 1, so it's smaller than 3, so it should not be changed. So you can see here, we say invalid size and we still have the old value, right? So we return it false here. And then last example, we set to a list of size 4, so it's bigger than the one of size 3. And it does get set and we print valid size. So in summary, just if it returns false, the modification doesn't go through. If it returns true, the modification does go through. So you can see you can control like what value we are allowed to set on a property, which is pretty neat. Now let's just take a look at the code a little bit, just behind the scene to see how Kotlin implements this. So if you take a look at a vetoable function, so it's a helper function, right? that returns us an object that extends observable property, right? And the main thing it implements is just before change. And all it does is, when before change callback of observable property is called, it calls the onChange function that we passed. So let's take a look at observable property and this before change. So observable property is read-write property, so it can be used for vals and vars, so for read-only and read-write property. Yeah, potentially more like for read-write, because for immutable values, yeah, it should be less useful. But so we have the value here that gets initialized to the initial value that we pass in vetoable, right? So we get initial value here, here, and we pass it to observable property. And now you can see it has two callbacks. It has two things that you can override: before change and after change. And it's with the delegate, what we are interested in is get value, which is what gets called when you call when you just access the property, and set value, which gets called when you set the value. And so get value is pretty simple; it just returns the value, so just the default behavior. Set value sets the value just normally, so default behavior for setting a value, but does two other things. It keeps track of the old value, right? And then before changing the value, it checks if before change returns false, then it returns and doesn't change the value. And then after setting the value, it just calls after change. Okay, we'll see how this is useful later for observable. But in vetoable case here, what we are interested in is here. So remember, vetoable here just says that before change is just whatever function we pass. And so if the function returns false, we don't do the modification. So exactly what we saw in the examples, the modification doesn't go through because we return early. But if it returns true, then we go here and we do set the value. And so that's how vetoable is implemented. It's just using this observable property which is a simple implementation of a delegate, right? Okay, so that's pretty much it for vetoable. Now let's take a look at the other variant, which is observable property. So, which is observable property delegate. So observable property delegate, similar to vetoable, takes two parameters: an initial value and the lambda, which is just a known change function. And the lambda will be executed each time the value of the property is changed, so after the value has changed. So a pretty simple example is just printing when the property value has changed, right? So we have a count property here. That is an int, initialized first to 0. And then when the value changes, which is the callback we are passing here, it just prints that the property, so here we have the metadata of the property, so we get the name. And it just prints that the value changes from the old value to the new value. So you can see here we also have the same 3 parameters that are passed to vetoable. Okay, so let's see here with count. So here we increase it to 1. So this is of course equivalent to setting count to count plus 1. So it does invoke the set value function of the delegate. A similar thing to count plus 1, and here also it's just count equal to count plus 10. So it does invoke set value, right? And so technically here we should get 3 prints, right? Here it should say that it changed from 0 to 1. Here it should say that it changed from 1 to 2. Here it should say that it changed from 2 to 12 maybe, right? So let's see if that's the case. So here, first one changes from 0 to 1. Then changed from 1 to 2, and then it changed from 2 to 12. So basically we can get we can have a callback gets invoked every time a property changes. So kind of like listener to changes to something. You can imagine this may be useful like for a list, where every time the list changes, we want to update a list of content, for example, on the UI. The second example is using an observable to do some action only if the property value really has changed, right? So let's see here. So I have here just a field data class that just contains a content string. And we have this variable list of fields that that is backed by this property delegate observable, initialize it to empty list. And if the old value is different than new value, so if the value has changed, so we are setting to a different value, then let's say we refresh a list. So a list that is maybe backed by content, that backs some content, let's say, and then only when it's changed, the value has changed, we want to refresh, let's say. And here I'm just marking a refresh list by just printing something, right? So let's see how that would work. So in our example here, we have first just one field that has the content field 1. And then here we change it to field 1, field 2. So in this case, here we should get this printed, right? Because this here is different than the empty list. In the second example, we should not get it. It should be changed as well, because this now we have two fields, field 1 and field 2. And so it's different than this one, so it should print this. But the last example, it should not, because it's the same as the previous one. So we should get this printed just twice, right? So let's run this and see. And that's what happens, right? Okay. Okay, so one last example that we are going to take a look at is for observable is that for observable delegate is that observable is useful sometimes to drive one property off of another. So let's say you have two properties, they are dependent on each other. You want to drive one property based on the other. So let's say we have this container class, which just, let's say maybe it's some UI element that for which the edits can be enabled or disabled. It can be edited or not. And so we have this other fields read only, that if it's set to true, we should, that means the container is read only, so we should disable edits. If it's set to false, then we should enable edits. So it's kind of the reverse condition here. So we have this property read only. So you can see now that container edit enabled should be driven by the read only property. And so we implement read only by observable. Initial value is false, which means initially the edits are enabled. And so of course we want to update only if the value is different, otherwise there is no need, right? And now what we do is we take the container, so we have access to the properties of the class. So we take the container and the property edit enabled. This gets changed based on the, sorry here, this is new. Gets changed based on the new value, right? Edit are enabled if we are not in read-only mode and are disabled if we are in read-only mode. And so that's pretty much it. And so now if we run this on this example, let's do. So I just create an instance of this class, and then initially it should be set to, let's see what happens initially. So let's comment this first. So initially it's set to true. This is this value, right? Even though the initial value is false here, we haven't yet changed the read-only property. So it does make sense to set this to true just so that both are like match, right? Now let's say I change this to maybe false, right? So if we change it to false, to not be read only, then what should happen? Edit enabled should be set to true, and that's what happens. But once we set it to true, then that means it's read only, the edit should not be enabled, and so you can see the value of edit enabled changed to false. And so that's what's happening here. So essentially this is an example of changing one property every time another one changes. Now let's take a look at the implementation here and do a code walkthrough just to make sure we see what's happening behind the scene. And so if we take a look, in a way similar to vetoable, it's just a function that returns an object that extends observable property, but this time it overrides only after change. And all it does, it's called the onChange function that we passed. And so if you take a look again at the observable property, it has this callback after change that gets invoked after the change to the property is made. And so this here is what we use for vetoable, but by default, before change return true. So for observable delegate, this will always return true, and so we'll always set the value. But then in after change, after setting the value, we'll call after change callback. And so every time the value of the property changed, this callback gets called. And this is the callback that observable delegate uses. Okay, so one last thing I want to show is, now that we've seen both vetoable and observable, let's see how can we, so here observable just uses an instance of, just extends observable properties. So let's see an example of how can we in our code extend this and take advantage of it. Okay, so let's see a couple of examples on how to create your own custom observable properties. So in this first example, I'm using an observable delegate to prevent assigning a value that is outside of a range. So I have a property, I don't want it to ever be set to a value outside of a range, so I want to reject a change that is not in a specific range, right? And so I can have, let's say, this thing called clamp that gets passed initial value and the min and the max for the range. And then in before change, so before changing the value, which is similar to be vetoable, if the new value is not in the range, then this will return false and the change will not happen. So this will return false and the change will not happen, right? But if it's true, this will return true and this will get set and it will pass. And so here I just have this variable a that is by clamp, and so I set the range to 0 to 10. So if we set the value to 5, it should be set, so this should be fine. So it should have 5 here, but when we set to 11, it's outside of the range, so we should stay on the old value because before change will return false and the change will not happen. So here we should get 5, and here if we set to -1, in the same way, it's outside the range, so we should get also 5, right? The value should not change. So let's run this. And we can see the value did not change. You can also implement before change and do something here. Let's say you want to observe the property. You can also override after change, right? And do both at the same time, which you can't do with vetoable and observable. Okay, so another example here is using an observable to prevent adding an element with the same value as the previous one in the list, which is basically in a way having a list without consecutive duplicates, right? And so here the way we implemented it is we have this without consecutive duplicates that extends observable property, and before changing we check. Of course, if it's empty, if one of them is empty, then we don't need to change because we don't need to check anything because we don't have two values that can be duplicates. But if that's not the case, then we just confirm that the old list value, the last element of the old list value is not the same as the new value. Here I'm assuming the new value is always that we add is always one element list. And so let's see an example here. So let's say I have a list of weights, which is just a list of doubles, and it's backed by this without consecutive duplicates delegate. So initially we set it to 1.1 and 2.2. So the value should be set fine because the old value is empty. But then the second example, we add 2.2, but you can notice this last value here is the same as this. So this will fail, and so the change should not go through. So we should still here have 1.1, 2.2. In a similar, but here, because 3.2 is different than 2.2, we should have this and 3.2. And so you can see we prevented consecutive duplicates that we would have gotten here, right? So let's run this. And that's exactly what happens, right? And And so you can notice here, this kind of allows you to even do some sort of consecutive, like some sort of custom data structure, right? A data structure that doesn't allow consecutive duplicates, for example. Definitely this one is not perfect. It has some bugs, but it can give you an idea on like how these can be useful. Yeah, I think that's pretty much it. Yeah, that's pretty much it that I wanted to cover. Thanks for watching and see you on the next one. Bye.